My name is Kevin Jones. Thank you everyone for coming to hear my talk. I've been working for NGINX for 2 years as a site reliability, or I'm sorry, as a technical solutions architect. Previous to working at NGINX, I was a site reliability engineer for yellowpages.com. So I have a background in operations, stuff like that. I previously managed NGINX at my previous job. So today I'm going to talk about caching, how you can utilize caching. I'm going to go over some basics of how caching works with NGINX. Go into a little bit of advanced functionality, advanced tuning, how you can kind of tune the cache to your actual instance. I'm going to talk about micro-caching, and then I'm also going to talk about ways to architect for high availability. So there's different ways that you can kind of approach that with NGINX. So everybody knows NGINX. We've had some pretty awesome, exciting news over the last couple of days about features and new applications that we're coming out with, but the meat and potatoes that got this all started was NGINX. And one of the main features that I feel is a little underrated is caching. NGINX can serve web content, static content, reverse proxy, load balancing, streaming media server, but a lot of people aren't using it for caching, and it really is useful for that. Just some fun facts about consumers using a web application. They expect for an actual website to load in 2 seconds or less. And a little bit less than that will actually abandon the website if it takes more than 3 seconds to load. So that is critical. Having that 3-second SLA is very important. And caching can help with that, right? Using NGINX as a cache, even in a load balanced tier, can really improve performance in many ways. And I'm going to get into details of how that can be set up. The idea is very simple. If you don't know, the idea is you have clients that are coming in requesting through a proxy cache. At that point, in this case, we're using NGINX. NGINX is going to see if that actual resource is on disk or available to be served, and it's going to check obviously like the response headers, the request headers to determine whether it should fetch it from the origin server, and then if it needs to, it will grab it from the origin server, then cache it, and put the actual key in the shared memory zone so that any subsequent requests that come through obviously will be cached. It's really straightforward. The core component to caching is the cache key. So the cache key has a default value, so you don't actually have to specify it in your configuration. This is the most common configuration, just using standard caching. It actually uses the scheme, which is whether HTTP or HTTPS, and then it uses the proxy host, which is the upstream group that gets selected when it's actually proxying to that group of servers. Then it has the full request URI, including any arguments, right? So there's definitely use cases where you're going to need to modify this, right? It's not always going to make sense to use this cache key. An example would be if you wanted to cache a certain cookie, you might have to add that cookie variable there, or a specific HTTP header or something unique to that cached asset that makes it unique. So that's just important to know. Setting up caching, though, really basic, is very easy with NGINX. You only need to specify the actual path on disk where you want NGINX to actually store the cached assets. It's actually got a large amount of configurations, but really just to do basic caching, you just need to tell it the name of the memory zone and how big that memory zone needs to be. The more cache keys that you plan on having, the larger the memory zone needs to be. I had one client that wanted to do 1 million cache keys because they had 1 million pages. So they had to drastically increase that, right? 10 megabytes is obviously not going to work for that. Then you just have to specify the actual size on disk of how much you want to dedicate for that cache. And then you just tell it how long you actually want it to store that cache there. This is nice because NGINX will manage that on its own. It has a cache process that actually runs, a cache manager process that's actually in process, constantly checking to see if it's been exceeded, and it will slowly purge and remove stuff as needed that's been sitting there for too long, or if it gets too large. The levels is very unique too. If you have a lot of cached assets, you want to increase that to 1 to 2. So it actually will split it up and create subdirectories of the cached assets. It basically takes the hash of the cache key and it creates subfolders and puts the responses in those subfolders so that you don't have one directory with 1 million files, right, and crash your server. Other than that, you just need to reference the actual shared memory zone in the location where you want to enable caching. So in this case, it's called cache, so we're just using cache. And then you just tell it, hey, what's valid? What is a valid cache? So HTTP status codes, obviously. You probably don't want to cache 500 errors. You don't want to cache 404s. Maybe you do, I don't know. But the idea is here that you can specify exactly what unique responses you want, and then you can tell it for how long, right? So in this case, anything that comes through that's a 200, 301, or 302 from the upstream, from this origin server, is going to be cached for 12 hours. So rather simple, 3 directives. There is always a chance where you want to validate the cache responses. So NGINX has one really cool feature called Proxy Cache Revalidate, which will actually do a conditional GET request to the upstream server, and it will check a modified header. So basically it says, if it's been modified since this date, which is what it has, go ahead and fetch and give me the new version. Otherwise, I'm just going to serve that response. So this saves on bandwidth to the origin server, right? Because it doesn't need to actually, it just has a conditional GET, and it won't actually pull that full request if it doesn't need to. Then you can say, hey, if for some reason that backend server is throwing a 500 error or any kind of error, or it's timing out, or if there's a specific HTTP status code that's coming back from that upstream server, go ahead and use the stale. So this allows you to kind of optimize and deal with an outage from the proxy cache as needed. So you might not even really be caching very long, but if there's a staled version laying around, stale is better than none, right? And NGINX can serve that. Caching with NGINX Plus, so as some of you might know, we have an NGINX Plus version of our software. It's basically a paid version with support, and it has some additional features. I do want to cover that just so that you guys are aware. We have an ability with NGINX Plus to manage the cache and purge the cache over an API. So this is a very basic instance of that. It allows you to map a specific request method to a purge method, and then it allows you to reference that purge. So what the proxy cache purge directive does is it says, hey, if there is a variable that you've defined here that has a value of 1, or actually anything other than 0 or none, it's going to execute a purge. So what that looks like here from a curl command is just, obviously here we're saying use the purge method on this particular URL. And in this case, I'm doing a wildcard purge, which it supports, which is really nice for being able to deal with large amounts of resources, right, using a URI. So if you were doing like example.com/images*, it's only going to purge the /images path, right? It's going to leave anything else in other directories or other URIs. We also have a dashboard in NGINX Plus. This is what it looks like. I tab to the cache because that's what's most important. That's what I'm talking about. The cache is basically it tells you the actual memory zone. It tells you what the state of it is. In other words, is it hot or cold? It's usually always hot, unless you're just not utilizing the cache at all. And it tells you how much memory of that memory zone is being used. And then it also tells you how big the actual cache is and how much of that disk is being used, right? So it allows you to kind of get an insight into what's going on with the cache, rather than having to do that by, using Linux commands and stuff like that. It also tells you the hit ratio, which is really nice. This will actually allow you to say, hey, I'm caching 100 gigabytes of data, but my hit ratio is 25%. That means that there's 75% of wasted disk space that really doesn't need to be there. We can kind of optimize that. And one way to do that is the proxy cache minimum uses directive. So this actually tells NGINX that only cache this particular resource after a certain amount of actual requests come through for that resource, right? By default, it's going to cache everything, at least if it comes through once. So this can be lower. This can be raised as needed. Like maybe you only want to cache things if they've been requested 5 times or 10 times or 20 times, and it's completely up to you. And this will drastically help with that hit ratio, right? This is just my personal thing. A lot of people don't think about logging with NGINX. They're using the default log. There's a few actual things that I always like to log when I'm dealing with cache, and this is just from troubleshooting perspective. The first is the request ID variable. If you guys don't know about the request ID variable, it's basically just a random integer, or not an integer, it's letters, n numbers, string, that's just generated on every request. So you can actually instrument that in your HTTP response by adding a header or basically allowing your client to see that, and then allow you to find the log instantly just by going into the log and greping for that request ID. Then I always log the proxy cache key if it's relevant. In this case, I'm just using the default cache key. You might have more than one cache key because you can define multiple cache keys in different areas of your configuration. But in this case, you can see I'm just saying PCK equals and the string. You'll notice here that I actually put the dot dot slash because it's not going to do that in the log. So that's just easy just to grab the whole thing, and then if you want to hash it, to be able to find exactly what the hash is or something like that. Then I also log the cache status. So this tells me on this request what was NGINX's behavior. Was it a hit? Was it a miss? Did it have to revalidate? What basically happened, and how did NGINX deal with that cache response, right? That's really nice because you can instantly identify if a client says, hey, here's the request ID, I'm trying to utilize your cache, but I'm not getting a cache response, then you can just instantly see what happened with NGINX and why it behaved the way it did. As I mentioned before, NGINX has the ability to just add a header, right? So in this case, I always like to add the request ID because it's just a random request ID. There's nothing sensitive in that, and it's just going to help me troubleshoot or help some other client troubleshoot with me by providing that. And then I also log the cache status. So if I want to know just by using curl without having to look at the log, I can just get the request ID, or I can grab the cache status just in the, like by doing a curl-i or something like that and seeing the headers. Really nice to be able to troubleshoot with that. So who here has heard of the concept of microcaching? Okay. So the idea is very simple. You have a large amount of content out there that is obviously going to be cacheable, right? Images, video, files, static files, things that are like very common and they're requested by a lot of users. And that's stuff that's just always, whatever, it can be cached however you want to. Then you have this stuff that's kind of like unique user content. So things that are unique to a specific user that's logged in, or maybe it's like sensitive information or whatever it is. You don't technically want to cache it because it just doesn't make sense from a utilization standpoint. But then you have this stuff that's kind of in the middle. It's dynamic content, but it is shared amongst maybe a group of users, a group of clients. So it does make sense to cache it. It could be maybe a web application that is constantly being updated and it's dynamic, but just by enable caching, if it has a large amount of traffic, can drastically improve the performance of that application. The concept is when you're using NGINX to proxy to an upstream server or an origin server, you want to enable keep alives. And that's just for common sense to be able to keep that connection and optimize the TCP connection to that upstream server. So that's the first thing you need to do. You're going to want to have that enabled. You're also going to want to, when you set up the proxy cache path, you don't need a lot of disk space, and you definitely don't need a very large inactive timer. So you can easily tune that down to very, 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 very small parameters. Then on the upstream server, additionally, you need to enable keep alives by turning on HTTP version 1.1, and you also have to clear the connection header so that connection stays open to the upstream server. So that's just part of keep alives, and it is recommended. And then you just have to say, hey, proxy cache valid any for 1 second, and that's it. That's very basic. So if you're getting a large amount of traffic flowing through here, everything's going to be cached for at least 1 second, right? But we can kind of optimize it a little more. There's a couple things you can do. Proxy cache lock is very nice because it's going to actually tell NGINX that only one particular request at a time can populate a cached asset. In other words, if he comes in for the file and he comes in for the file, whoever came first, NGINX is going to cache that, and it's going to have that actual client request wait until it's finished populating, which is a timeout of 5 seconds. And that can be modified too. Then we say proxy cache background update on, which basically tells NGINX to go ahead and update a request for a specific asset if it comes in, doing a background update, but serve the version that it already has in memory to the client. So this allows it to do kind of like a background update of that file or that resource. Then we just say use stale in the case that NGINX is in the process of updating. So It's just 3 little optimizations that drastically improve the performance of the micro cache. So this was just a test that we did. Owen, actually the head of product, did a blog series, and I just wanted to throw this up just to show, like theoretically, the performance increase that you get from using micro caching. On a WordPress instance, we were doing 5.53 word requests per second using NGINX just as a standard proxy without caching, 5.63. So there's actually a little bit more improvement. But the minute that we enabled basic micro caching, you can see the drastic request per second increase that was gained. Then, when we actually enabled micro caching on a 1 gigabit NIC, by the way, so that was the network card that was used. Theoretically, you could get upwards in the 3,000-ish requests per second. So you can see it's drastic improvement of the performance. But you do have to be able to do that, right? And it has to be a large amount of traffic. If you have a web application that's not receiving a lot of traffic, micro caching might not really help you that much, right? In this scenario, we were really hammering the server, and we're able to really drastically get those results. NGINX also is going to, so by default, NGINX will comply with any kind of cache control headers. So if a browser sends through some kind of particular header, NGINX is going to go ahead and assume that that's how it should behave. There's definitely a way that you can ignore headers, though. So if you see that for some reason maybe there's an application that isn't caching, it could be a header causing that problem. So what you can do is actually use proxy ignore headers to actually ignore that. This is a cool feature. If you actually want to have a client that you just want to allow them to bypass the cache at any point, maybe it's particular user that needs to be updated, they can't deal with any kind of latency in their response. You can actually set, so NGINX will search for any of the variables that you have here, same kind of mechanism as the proxy cache purge. If those variables contain a value of 1 or something, but not 0 and not none, so basically if the variables equals anything other than 0 or nothing, it's going to bypass the cache no matter what and fetch it from the origin server for the client. So this is nice, like I said, if you need to be able to just completely bypass the cache for specific clients or specific users, and you just supply them with a special HTTP header they need to send through on the request, or maybe give them a cookie, have the application set a cookie and check for that cookie, right? This allows you to have more control about what's being actually served from cache. Who here has messed with split clients? A little familiar with it? So I always like to talk about split clients because a lot of people don't really utilize it much. This is just a scenario where maybe you had a large amount of cache resources. Maybe you're caching video, maybe you're caching images, and you have a large amount. There might be a chance where you need to have more than one hard drive on that server, right? So in this case, what we're doing is we're actually hashing a specific variable and setting a new variable based on the hash. So what this does is it's going to hash the request URI, so the full, basically the path of the actual request. And based on that hash, it's going to place, based on the percentage, into, like, I like to consider it buckets. This is a really good way to explain it. So we have a 50% bucket and another 50% bucket. Each bucket is equal in size. When that request URI is hashed, depending on where it sits in that range of those buckets, so 0 to whatever, 100,000 and 101 to whatever, 200,000, it's going to basically set a variable dynamically on the fly. So it's basically just a randomized hashed variable with a set percentage. So this is commonly used for like A/B testing, right? Maybe you want to do like 5% to one upstream, and you want to do 95% to another upstream. But it can be used for other things. Specifically here, we're saying, hey, there's 2 hard drives. I want to split the cache across those hard drives. So in this case, it's a consistent hash. So if a request URI is always going to go to one particular hard drive, and then another request URI might go to a completely different hard drive. And then we can use that variable that's dynamically created over here in the configuration. Make sense? So, in terms of high availability, a lot of people are using NGINX in some kind of high availability fashion, right? They might be using our keep alive D scenario where you're using 2 instances and you're using a shared IP and you're floating requests between two actual instances. You might have a layer 4 load balancer sitting in front of NGINX. What I'm going to talk about today is particularly how you deal with a large amount of cache. If you need to be able to have more than 1 or 2 instances of NGINX, what's a good way to utilize the cache? There's two really main approaches. One is sharded cache, so designed for high capacity, and then we have actually a shared and a replicated cache. I'm going to show what those look like here. The shared cache is basically you're doing multiple tiers of cache. So you have a primary and you have a secondary instance. Typically, this would be handled with high availability, as I mentioned before, with like keep alive D. And in this type of scenario, we're doing active passive. So the single instance, the primary instance, is always going to be calling the secondary instance for any cached assets that need to come through. So this allows NGINX to replicate that cache and have the same cache response on each of those. And in the case that one of those does go down, it can instantly call to the next server, and it's already going to have that cache response. So you don't have a loss in actual cache responses, right? It's 100% availability unless both of them go down, which I would hope that doesn't happen. Same thing goes if the secondary goes down. It has a failover to the origin server where it won't actually proxy to the second server. It will just grab it from the origin if needed. So this allows you to, like I said, keep 100% availability of your cache resources. And you could do this as often as you need to. Like if you need to do a 3-tier, you technically do a 3-tier. You just need to use keep alives. You need to do SSL optimizations. You need to think about latency. If it's in the same data center, you're probably not going to have any issues with any of that. The configuration looks very simple on the primary cache server. Just in the upstream group, we're just setting a backup. So this backup is the origin, right? So if for some reason that secondary server goes down, it's unreachable, has an error, whatever, the primary cache server is just going to fail over to that origin server, right? And then on the secondary cache server, we're just talking directly to the origin server. Nothing special. It's pretty much the same configuration as before, but we're just obviously stripping out the secondary server because it's going to proxy right to that, to the origin. Another thing is if you want to shard the cache, right? So the shared cache is designed for high availability, having a full cache available all the time, and you cannot deal with any particular resource not being available in the cache. Then what you need to think about is how you can shard this your cluster of cache servers. So there's a cool directive, load balancing directive called the hash load balancing directive, which allows you to hash any particular set of variables or a variable to route requests, right? So what we do is we set the load balancing algorithm on the load balance tier. So you have a separate load balance tier that's handling load balancing in an NGINX layer. Then you have a cache tier that's only strictly designed for doing caching. And in this scenario, the actual hash load balancing that we're using is based on the cache key that you set in your actual cache. So that way, the same requests are always going to be proxied and sent to the same cache server, right? You're never going to have an instance come down and go to a different cache server. It's always going to get routed to the same cache server on the back end. This makes it a consistent hash of that proxy cache key. Then as needed, obviously that cache tier is going to contact the origin server or whatever it needs to do to cache those resources. In this scenario, you can really scale this out, right, as needed. You can have more load balancers, you can have more cache, and you're only going to lose your cache based on the amount of instances you have. So if you have, in this case, 4 instances and you lose 1 cache server because it goes down, it's going to redo the load balancing for everything that's going to that one that went down, and you're only going to lose 25% of that cache. But you're drastically going to be able to have a lot more cache resources as needed, given the amount of actual instances that you have. So we have some people that are doing this with 10 servers, right? So if one goes down, they're only losing 10%, right? And it will repopulate and redistribute as needed. If the server comes back up, obviously it's going to go back there and it's already going to have the cache. It's not like it's going to go anywhere. So it's just for the amount of time that that actual cache server goes down. What that looks like here is, like I said before, so we just have an upstream server, and we use the hash load balancing algorithm, and we specify the full cache key, right? So this is just the default cache key, and then we set it to consistent so that it's a little more consistent. It's just a different kind of a hash. It's a little more consistent for routing. Now you can do some interesting things where you can combine the two stacks. So if you, for some reason, don't want to have a separate load balance tier and you don't want to have a separate cache tier, you technically can get away with kind of merging them together like this. In this scenario, you actually have some kind of load balancing in front, whether it's keep alive D or round robin DNS or a layer 4 load balancer sitting between the client and this cache tier doing high availability. But then within there, it's doing its own internal load balancing and internal cache clustering. So you technically could do something like this. The configuration gets a little more confusing, and to me, it's a little harder to manage, but it's definitely something you can do. And then you can even go a step further and take the sharded approach, and you can split your cache. So you can still do load balancing, and you can do caching on that separate tier. So you could do something like, things that are really important that need to be cached, that are considered a hot cache or something like that. Maybe you want to utilize in-memory cache or something like that. You could have it your load balance tier, and then you still would have this separate cluster on the back handling long-term, large files, video, right, stuff like that. So that really the options are endless, with NGINX in that sense. You can really do a lot of cool stuff with that. So you're still doing the consistent hash load balancing in this scenario. But you have access to the full NGINX configuration in both locations. If you guys haven't been to our website, this is just our nginx.org website. It's a great resource for any kind of documentation for NGINX. Check it out. Most importantly, I always like to tell people to bookmark the directive index. So you can easily look at all the proxy cache directives just by searching for that, and they're all there. So there's a lot of cool stuff you can do that I didn't really cover in here. I definitely recommend going through there. We have a lot of blogs on our website. I've written some blogs. There's some really good ones on caching. So if you go up here to our blog site and just search for caching, they'll pop up for you. And I also did a webinar where I go into a little bit more detail on all the cache directives. So if you guys have some time to check this out, it's an hour long. So this talk was only 40 minutes, so I kind of rushed through it a little bit. But this will give you a little bit more insight if you guys are interested in learning more. We also would like to give you guys a developer license of NGINX Plus. I don't know if you guys have seen this slide, but the code to do this is KJConf2017. And you just go to nginx.com/developer-license, developer-license, and put that code in, and it's good for a 1-year developer license. So you guys can try out NGINX Plus if you guys are interested. That being said, thank you guys for coming, and I'd love to answer any questions you guys have. Yeah?
A couple things about NGINX Cache. The wildcard purge, will that ever be available in the open source version, or is that on the roadmap for Cache?
So there is an open source module for purging now that I know that's community driven. It's like a module that can be built dynamically and loaded, so there's that option. It doesn't work the same as ours. I don't think it's not exactly the same kind of implementation, but you can get by.
If I understand correctly, the implementation which you're suggesting there does not offer wildcard.
That's possible. That is possible.
Have you seen other wildcard purges out there
which
might be applicable in the open source product?
I have not. I'm sorry. Yeah.
Is there LRU cache? Did I see that there?
LRU? What's up?
Recently used. So Varnish, for example, you're able to set up a LRU or a least recently used configuration.
No, we don't have anything like that. Nope.
Gotcha.
Yeah. Yeah, no worries. Sure.
Any best practices you can share caching byte range requests?
Yeah, so the question was what kind of recommendations for byte range requests? So definitely NGINX does support caching byte range requests. We have a blog about that that you guys can read about. We have what's called the slice module, which will allow you to break up a request into sub-requests, so to an upstream that supports that. So if you have like a large video file or like some kind of large request, you can split up into smaller segments and cache those. And it's just a matter of adding the HTTP header, right, to the cache key. So in your scenario, if you're trying to cache something through NGINX, that NGINX has a unique, you'd want to add that header to the cache key. If you're using the slice module, same thing, you need to add that header to that as well. Does that make sense? Because the actual, you have to add that HTTP header to the cache key, otherwise it's going to assume it's the same file, right? It has no way to know that it's a byte range request. So that header is usually like X bytes to X bytes or whatever.
Are they usually discretized to certain boundaries so that it's predictable in that manner?
Yeah, they should be, yeah. I mean, it's like ranges, isn't it? Yeah, it should be a range. So you know that that's a particular request for that range. Does that make sense?
Yes, but the problem is when you do that, if somebody comes in on the second, it's going to actually redo that whole cache 1 second longer for that slice.
Okay. So yeah, that would make sense, yeah. Yep.
Next size parameter support percents?
The question was, does max size support percents? And it does not. Yeah.
The approach by white cards, how does that work with custom cache keys? But is it possible at all?
So I'm sorry, can you repeat the question?
Approach by white card with the star.
Yeah.
Does that work with custom cache keys?
Custom cache keys? Yeah. So it's still gonna. So NGINX. So the question was, is that does wildcard support for custom cache keys? So NGINX, when it requests a request and processes a request, it does regular expression matching to find out in the configuration where it's trying to send that request. So if you have the purge command there in that particular part of the configuration and it gets routed there, and you have that you've set the specific variable that's going to enable purging, it's going to purge it. Yeah. So yeah, it's definitely would. What else? The only thing that I guess the whole point is what I'm trying to say is the only thing that makes the cache key unique is the hash, right? So, any other questions? Yeah.
Probably a bit left field, but with the shared cache storage location on disk, can that disk be shared amongst multiple cache engines?
So the question was, can the actual disk be shared amongst a cluster of NGINX instances or something? So like you could do something like, I guess, NFS, like some kind of network file system, but it's not recommended with NGINX because NGINX is actually very sensitive to disk latency. So it's not recommended to do that, and that's kind of why we have this kind of approach instead, using more of a load balanced type shard. Does that make sense? So NGINX just, that's just the design of NGINX. So the question is why disk and not memory? If you want to mount memory to a disk on Linux, you could definitely use memory, and some people do that. But yeah, it's just it's just how the implementation of our caching is. Great, those are good questions. Any other questions you guys have? Oh, yeah, sorry. Oh. There you go. Yeah, thank you guys for coming. Really appreciate it. Oh, did you have a question too? No? Oh, yeah, no worries. Thank you guys, seriously. Appreciate you being here. Thank you.